Good afternoon, Algebra 1 students. So, Mr. Chen here. So, today I would like to talk about Chapter 3. So, this one is all about the linear function. Okay, so we'll look at that. It's like a summary of the Chapter 3, linear function. So, started off with 3.1. So, again, the main purpose of setting up the video today, just want to help out the student that to refresh, to recapture some of the concept that they learned from Algebra 1, or a student currently taking Algebra 1 or needs some help for Algebra 1. So make sure that you guys watch this video. Again, if you guys like this video, so please click the like button and also click the bell. Okay, so subscribe to the channel. So appreciate it. Okay, so now here's what we're doing. So for the first type of problem, it's about determining the relation. It's a function. So there are a couple ways that we can find out the relation is a function or not a function. Okay, so by looking at the xy table, if you don't see any repeating x value here, so that means the relation is a function. Again, if you don't see any kind of repeating x value for the rows in the column, the x value, no repeating x value, so it is a function. So we got 2, 5, 5, 11, 7, 19, 9, 12, 14, 3. So according to the list with the input, the x value, or the independent variable, there's no any repeating x values. So for the relation given, it is a function. So this one similarly, so 0, 1, 5, 6, 7, 9. Again, there's no any repeating x value. It is a function. So what about for number 2? So for number 2, if you try to do like a vertical line, so for the vertical line test, so let's say that the graph is given. If you find out the line touches the graph at more than one point, so that means the relation, it's not a function. So if you just draw any line right here, it could be here on the left, right here in the middle, right here on the right. If you don't see any, more than one point of intersection, so that means it is a function, but this one is not. If you try to draw the line here in the middle, so you see that 2 points are being intersect. And then the other one is called a mapping diagram. So the input column and the output column here, kind of like an XY table. So we got 11, 7, 15, 8, and then 22, 7. Again, there's no any repeating x value. Okay, so it is a function. So now, what about for number 4 right here? Word problem. So normally student having trouble with the word problem. And now let's look at that, this one here. So what we found, the function y equals 10x plus 100 represents the amount y in dollars of money your bank account after you babysit for x hour. Identifying the independent and dependent variable. If that's an independent variable, so that means it's always considered the variable of x. Because for x here, you can put in any number you want, any real number. It can be negative, it can be 0, it can be positive. But in this case right here, x is representing the time. So x must be greater than or equal to 0. And now this one is saying that define the variable, so x would be the independent variable. Okay, so x, it's called the independent variable. And then for y here, then that would be called the dependent variable. So again, y, it's based on the value of x. If you try to set up the xy table, plug in a number, so let's say x, so let's just say that your babysit just for 1 hour. So 1 hour, 1 times 10, that's 10 plus 100, so it's 110. 2 hours, so 2 times 10, 20. 20 plus 100, so 120. So like that. And then for b, so you babysit for 4 hours, so find the domain, the range of the function. So this one, just find out the input value. So x would be 4 hours. So that would be the domain. So domain is just the x values. And then y. So plug in that 4 right there. So we got y equals 10 times 4 plus 100. So we got 40 plus 100, then that'd be 140. So $140. Okay, so just like that. And now let's find out the next section here, linear function. So for the linear function, this one it shows like a regression. As you can see that here from 6 to 10, 10 to 14, 14 to 18. So the pattern here is just by adding 4 each time. And then for the output value, we got 5 to 9, 9 to 14, 14 to 20. So this one is just by adding 4, adding 5, adding 6. So as x increased by 4, y increased by a different amount. So this one it shows the rate of change. So the rate of change is not a constant. Okay, so now let's look at that, the table with the graph. So does the table or the graph represent a linear or non-linear function? If that's a linear function, it shows the consistency of the growth. Okay, so let's look at that here. So for 5 and 6. Okay, so for number 5, so use the table. So basically one thing that we can find out here, it's about the pattern. So from 2 to 7, so simply by adding 5, 7 to 12, by adding 5 again, 12 to 17, by adding 5. So this one, it shows the consistency of growth. And then 2 to -1, simply by subtracting 3. -1 to -4, subtract 3 again. -4 to -7, so subtract 3 again. If the table shows that the consistent growth or this consistent decrease, so definitely, so it is a linear function. Now what about the parabola? The parabola, it's not linear. The reason why that is because it's not a straight line here. And also it shows like a different rate of change at each position. Okay, so this one, it's not a linear function. So the first one, it is linear because that it shows the consistency growth and decrease. But the second one, it's called a non-linear. Okay, it's not a straight line graph. Okay, so now let's see what else that we have for the rest of this. And for number 7, okay, so word problem, that's a lot of things, a lot of people kind of consider the word problem. It's not just related with function, but also could be related with a lot of real life situation. Okay, so I'll just put it right here on the same slide. Okay, let's make it bigger. So the function y equals 60 minus ax represents the amount y in dollars of money you have after buying x movie tickets. Find the domain of the function. Is the domain discrete or continuous? Explain. So graph the function using the domain. So first thing first, let's find out the domain of the function. So y equals 60 minus ax. Okay, so far, and $60, so that means you have $60. So for the movie ticket, each ticket is $8, and you want to find out how many movie ticket that you can purchase. So basically we can just sketch the graph first, so negative ax plus 60. Okay, so started with the x-axis, y-axis, perhaps. Okay, so let's just make the graph first. So for the scale, got to be very careful with the scale. For the y scale, I would like to use 20 or 10. You can always customize the scale, the x-axis, the y-axis. So 30, 40, 50, and then 60. And then for the x-axis, so I just want to call it by 1, 2, 3, 4, 5, 6, extend it a little bit, 7, and then 8. So according to the y-intercept, so the y-intercept here, then that would be considered 60. Okay, so 60 is all the way up here. Negative 8. So negative 8 is considered negative a over 1, so rise over run. So down a unit, so all the way down to 52, and then 1 unit to the right. And then 52 minus 8, then that'll be 44. 1 unit to the right, so it's over here. And then just keep doing that, extend it, so it's going to be a straight line. So going down this way. So it looks like eventually it's going to hit some point over here. Okay. Like that. So now let's find out the domain for the functions. So it looks like the domain, it's all the way from 0 to 5 point something. Okay. So basically what we need to do for the domain, we need to find out the x-intercept. So in order to get the x-intercept here, we need to set y equal to 0. So 0 equals negative ax plus 60. So that means 60 equals negative 60 equals negative ax. So that means x equals 60 over 8. And then over here you want to reduce. It's not divisible. So once you reduce, so this number turns out to be 15 over 2. So half of 15, which is 7.5. So this one should be a little bit further down. So the unit that I have here, the scale, it's kind of not matching it. So the line that you want to do, so make sure that we draw the line, so extend it all the way to 7.5. Okay? Yeah, so it's kind of difficult because the scale here is a little bit inconsistent. So one is kind of wider, the other one is kind of narrow. Okay? So once we find the x-intercept, so 7.5. So that means the domain is from 0 all the way to 7.5. And then another thing is that to find the range. Well, the range is pretty obvious, the possible y value. So this one is from 0 to 60. So when is all the money's gone, buying all the tickets, so it's going to be $0. Okay, so from 0 to $60. Okay. And also for the number of tickets that you can purchase, you cannot purchase like half of a ticket. So this one you have to round it up. So 7 tickets. So instead of putting 7.5, so let's say 7 tickets. And also this one, it's from 0 to 60, so you only have $60. And for those you might be wondering, is this considered continuous or discrete? So if that's a straight line, normally that's the way we connect it. As what I mentioned about, there's no such thing like half of a ticket or a quarter of a ticket. So this one, it's just like a bunch of dots. It's just considered a discrete graph, okay? It's not going to be a straight line. The line, I just want to connect all those points together, so it's discrete. The reason why it's discrete, because that the number of ticket, it's always the whole number. It cannot be 1 and 1/4 ticket. It cannot be 2 and a half ticket. There's no such thing. It's always the item, so it's always a whole number, integer. Okay, so pretty much that's it. So for this section here, and let's see what else that we have going to the next section, 3.3. So 3.3, what this one is about is just evaluating. Okay, so the linear function is given, so you want to plug in a number, find out the exact y value, or the other way around. So the y value is given, you want to find the value of x. Okay. And then the other part of it, it's by making the linear function using the slope and the y-intercept form, perhaps. Okay, so now let's do that. So instead of doing all this, I'll just do the even. Okay, so the odd problem, those are the ones that I can try. Okay, so started off with number 8. So number 8, evaluate the functions when x equals -3, 0, and 5. So one thing at a time. So we do know the function already. And all you need to do, you just need to plug in a number. So f of -3. So then that would be -3 plus 8. So that would be 5. And then the next one, f of 0. So then that would be 0 plus 8, which is 8. And then f of 5. So then that would be 5 plus 8. So 13. And then for number 10. Number 10, so given that the functions, k of x is 7x. And the value of k of x, which is the value of y, it's given already. It's 49. So the value of the dependent variable is given already. So plug in a number. So 49 equals 7x. Divided by 7 both sides. So we do have x equals 7, just like that. And then 12 and 13, so basically you just sketch the graph with the linear function. Again, as the model that I showed you earlier, so you need to allocate the slope and the y-intercept first. Another way you can do it, you can always set up the xy table if you don't like to use the slope or the y-intercept. So plug in a number for x, so x, it's called the independent variable. That means we can plug in any number for x here because that's the linear model. So let's plug in 2. So negative 2 times 2, then that'll be negative 4. Negative 4 minus 3, then that'll be negative 7. So we got 2 comma 7, negative 7. So 1, 2, 1, 2, 3, 4, 5, 6, 7. Well, that's down. And then plug in something else there. So let's say we do have 0. So negative 2 times 0, that's 0, minus 3, so negative 3. So 0 comma negative 3, the y-intercept. And then all you need to do, just connect the dots. Okay, so that's going to be the straight line with this model. It's a linear function. And also make sure that you put the arrow here, so it shows the continuation. Okay, so that's it for this section. It's pretty short. And let's see what else. And 34 is more graphing. So again, this one that requires using the xy intercept or using the standard form to sketch the graph. Okay, so let's do number 15, 16, and 17 for this. So graph the model using the standard form of a line. Okay, so I'll put it to the new page right here. Okay, so for 15, 16, and 17. So 15, in order to find the y-intercept, so x-intercept, so that means you want to set y equals 0. So plug in a number, so we got 12, negative 12x, minus 3 times 0, so that equals 36. So negative 3 times 0, that's nothing. So negative 12x minus 0 equals 36. So in other words, negative 12x equals 36. Divided by negative 12, so we got x equals negative 3. Okay, so we divided by negative 12, both sides. So once we find the x-intercept, we write it. So we got negative 3 comma 0. And now the next one, find the y-intercept. So the way to find the y-intercept, excuse me for a second. So the way to find the y-intercept, then that would be setting x equals 0. So negative 12 times 0 minus 3y equals 36. So negative 12 times 0, that's 0, minus 3y equals 36. So in other words, negative 3y equals 36. So solve for y, divided by negative 3 both sides, so y equals negative 12. So that means 0 comma negative 12. So sketching the graph, so using the x-axis, the y-axis. And the point where those x's intersect, so it's the origin. And what we found here, so started with the x-intercept, negative 3, comma 0. And then the y-intercept, 1, 2, 3, 4, 5, 6, 7, 8, keep going. 9, 10, 11, negative 12, all the way down here on the bottom. And then all you need to do, just connect those two dots. It is a little bit tedious, so we got to be very patient. So you need to find out 2 points first, because anytime that you do have 2 points, we can always form a line with 2 points. Okay, so simply just connect those two dots. Okay, again, put an arrow, shows the continuation. So now, for those you might be wondering, what about if that's just a number, y equals negative 5? Well, if y equals negative 5, that means it's always a horizontal straight line here. If x equals a number, that means it's a vertical line. Okay, so y equals negative 5, so 5 unit down, 1, 2, 3, 4, 5, down here. So 5 units. Okay, like that. And then x equals 6. So 1, 2, 3, 4, 5, 6 units to the right. And that one is going to be a vertical straight line. So normally you have to grab that on a different xy plane, but I just want to put them all together. Okay, so this one x equals 6. So y equals -5. Okay, so now let's see what else that we have for this chapter. So it's like 7 sections for this whole unit. And then 3.5 is graphing the linear equation in slope-intercept form. It's just like the one that we did, so finding the slope, finding the y-intercept, and then basically using that, the y-intercept and the slope, so we can figure out 2 points. So utilize those two information so we can sketch the graph. So let's do the one with the table. And let's do the one with the equation. Okay, so we'll do (19). So the point represents by the table line on line. Find the slope of a line right here. Okay, so this one's 3.5. So in order to get the slope here, we need to get 2 points. You can select any random points on the table. So normally I would like to choose the one that is right in the middle. So 3, -2, and then 3, 5. So basically this one tells me the value x1, y1, and then x2, y2. And then we're using the slope formula, y2 minus y1 over x2 minus x1 to get the slope. Well, you might be wondering, is that the only way to do it? Not really. There's another way to do it. It's just by counting the rise and the run from the y value and then the x value. So y2 minus y1, so 5 minus -2. And then x2 minus x1, so 3 minus 3. So you may notice that the numerator, it's a 7. And then the denominator is 0. So anytime that you divide it by 0, it's always considered undefined. We don't know what that is. So the slope is undefined. Cannot be determined. Okay, so now what about the other one? So sketching the graph by finding the x-intercept and the y-intercept. Okay, let me go back to this page. Graph the linear equation, identifying the x-intercept, okay? So first thing that I can do, you can always rewrite it with the slope-intercept form. Certainly we can do that. But this one is saying that you need to find the x-intercept first. Again, we need to let y equal 0. So -5x plus 0 equals -10. So in other words, -5x equals -10. Divide both sides by -5. So we do have x equals 2. So that means the x-intercept is 2, 0. Okay, so we need the x-axis, the y-axis. And then the origin right here. So 2, 0. Now the thing is that 1 point, it's not enough to sketch the graph of a line. So we need to create another point. So perhaps finding the y-intercept. So the way to find the y-intercept, that means we need to set x equals 0. So let x equal 0. So solve for y. So that means y equals -10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down the bottom. And then all you need to do, just connect the dots. Get a ruler, connect them, right? To get those 2 points connected. And here's what we found. Okay, so now let's see what else that we have for this unit. It's a long unit. It's a lot of things involved right here. Making a graph, transformation. Okay, so let's talk about the transformations for a little bit. And then we'll do 26 through 30. So for transformation of a line, so let's talk about the general structure. So let's say that we do have a functions f of x. Whoops. Okay, Okay, so this one I need to use a pen, not a marker. So let's say that f of x is like 3x plus 1, okay? Just like a normal line here. And then you have to find out that y equals a times f of x minus h, and then plus k. Or sometimes you're dealing with y equals a, f of quantity of b times the quantity of x minus h plus k. So let's use this form. So a right here, it's called the vertical scale factor. The vertical scale factor. So what that means is if a is greater than 1, so it's going to be a vertical stretch for the line. So vertical stretch. If a is less than 1 but it's greater than 0, then that would be considered a vertical shrink. Okay, so that's the same kind of concept we apply in algebra, algebra 1, algebra 2. So b is called the horizontal scale factor. So similar to the a, the vertical scale factor. So if b is greater than 1, so that means it's considered a horizontal shrink. If b is less than 1 but it's greater than 0, it's called the horizontal stretch. So sometimes you see that it's a horizontal compression. So if that's horizontal compression, then that would be considered a the value of b, which is less than 1, it's greater than 0, like that. And then h right here, the same value of h, it's called the horizontal phase shift. So that means you want to shift the graph either to the left or to the right. The horizontal phase shift. And then the value of k, it's called the vertical translation. So that means it shows the graph whether that's moving upward or downward. Okay, so like this one here saying that h of x equals f of x plus 1. So with the constant k equals 1, so that means the graph is going to be shifted 1 unit up. Because that one, the value of k, it's given as the vertical translation. So 1 unit up, because that's positive. And then what about there's a negative sign right here in front of the whole function? So anytime they see the negative f of x like that, that means this one is considered a reflection. It's a reflection over the x-axis. So let's say that we did a graph like this. So that's reflected over the x-axis. So that means it's going to be going down this way. Reflected over, going down this way. And what about if we see any negative sign right next to the variable, like that? So then this would be the reflection over the y-axis. So a lot of things that you guys need to absorb and understand right here. Reflections, so 2 different types. So let's say we do have a graph here, a line in the first quadrant, reflected over, so that means the line segment is going to be going this way, back to the second quadrant. So that y-axis would be the mirror, or the line of symmetry. Over here, the x-axis would be the line of symmetry. So this one is showing that negative outside, so reflected over the x-axis. And then what about 30? So 30 is showing that h of x. So that equals f times f of 6x. So 6, it's right next to the variable, so that's the value of b. Again, if b is greater than 1, so that means it's considered a horizontal string by the factor of 6. Okay, so horizontal string. Okay, so now let's see what else that we have for this lecture, or the review for chapter 3. So the other one just described the transformation if f of x equals x, so g of x equals 5x plus 1, so that means, so the graph is going to be considered 5 unit with the horizontal strength, with the 5 unit scale horizontal strength, and 1 unit up vertically. And then finally, so sketch the graph for the absolute value function. So we do know that the absolute value, the parent graph, is always a V shape, okay, as you're looking at this one right here, the black one. So absolute value of x, it's always a V shape. So as you can see that the slope of the negative sign right here, the slope is negative, and the slope of the other side right here is positive because this one is going down, negative slope, going up, positive slope. So now, let's do a couple problems here. So absolute value functions, eventually it can be broken into the piecewise functions. We'll get to that in one of those chapters. So graph the functions, compare the graph to the graph of y equals absolute value of x, or f of x equals absolute value of x. So for absolute value of x, it's always going this way. And you might be wondering, this one, it's written as absolute value of x, because once you break it apart, it could be negative x, it could be positive x. So with the slope intercept form, the slope here, it's what, negative 1. And then the slope here, it's considered 1. Okay? So it's a V shape. So now what about once you deal with things like with the transformation? So normally for absolute value functions, so we do have a times x minus h, the quantity of x minus h plus k. Again, a, we just talked about that earlier. This one is called the scale factor, the vertical scale factor. And then h, which is just the horizontal phase shift. And then k, which is considered the vertical translation once again. So for number 32, so what we found here, m of x equals absolute value of x plus 6. Compare and contrast. So a, it's 1, so it's a normal V shape. There's no stretching, there's no shrinking. And then h, it's not given, so 0. And then k, it's 6. Another thing is that the value of h comma k, it's always the vertex. What I mean by the vertex is either the highest position or the lowest positions of the curve. The highest or the lowest position of the V shape. Or you can say that's the center spot, the central positions of the V shape connecting the negative positive slope. So this one, the center spot here is 0, 6. So it's right here on the y-axis. Another thing that you might be wondering, if I unbreak it, if I just break it apart, so this one is written as y equals plus minus x plus 6. That means it could be written as y equals x plus 6, y equals negative x plus 6. So y-intercept, we found it already, it's all 6. But the thing is that the slope here, it's rise over run. So up 1 unit, 1 over to the right. And also for the negative slope, could be up 1 unit and 1 unit to the left. Because the slope could be written as negative 1 over 1 here. The slope here could be written as 1 over 1. So positive slope, negative slope, so it's a V shape. So going this way. And now what about for 35? Similarly, 35. So let me get more space for this one. So 35, again, just identifying the value of a, h, and k. And again, you see that the negative sign, it's right outside the function, so that means it's going to be reflected over the x-axis. So for this one, which is what? R of x. So that equals negative 1/4 absolute value of x. Okay, so identifying the value of h and k. So h in this case is nothing, so 0. K is nothing, so 0. So start at the center or the vertex, 0, 0. And then this one, once you break it apart, so that means y could be negative 1/4x. And also y could be positive 1/4x. So that means this one is 1 unit down and 4 units to the right. And also this one could be written as 1 unit down, but it's 4 unit to the left. Okay, so once you get that, the points. simply just connect them. So this one is a wider V shape because the slope. So 1 unit down, 4 units to the left, or 1 unit down, 4 units to the right. And then the other one just described the transformation. So this one saying that it's 2 units shifted to the right, 4 units up. And then for g of x, well, you want to compare that, okay? So let me put it to the new slide here. Can I simply just tell about that verbally? So there's certain things that you have to simplify. So making a graph for the function, so that's something you guys can do. So putting the new vertex. So h is 2, so k is 4. So 2, 4, that would be the new vertex. So 1, 2, 1, 2, 3, 4, all the way up here. And the slope here, so this one is not showing any number right in front of the variable, so it's always 1 over 1. So up 1 unit, 1 over to the right, or up 1 unit, 1 over to the left. So for the parent graph, it's just like that. But now this one is saying that for g of x, it's considered absolute value of 3x minus 2 plus 4. So you might be wondering the 3 right there, what's the point of having the 3 right there? Again, the 3 here, it's just a scale factor. We can always reduce. We can always put it out, so 3. And then whatever that's remained, just rewrite it. So x minus 2 over 3. Close parentheses. 4, that's just the value of k. As you can see that here, absolute value of 3, that's 3. With the absolute value of x minus 2/3, and then plus 4. So for this one, it's kind of changing the vertex a little bit. Okay, so instead of making that the vertex at 2, 4, we're making the vertex here at 2/3, 4. So for h, k, this one is a little bit different. So 2/3, 4. So 1 is over here, 2/3, so pass through the middle, and then 4 units up, 1, 2, 3, 4. Okay, so it's all the way up here. And then what about this one? This one you can just assume that it's a slope. Could be positive, could be negative. So 3 units up, and then 1 unit to the right, or 3 units up, 1 unit to the left. So compare the graph of g to the graph of f, okay? So let's finish making a graph here. So 4, 5, 6, 7, 8. So this one's 3 units up, 1 unit to the right, 3 units up, 1 unit to the left. So just compare the graph right here. Obviously, it's a different position for the vertex. And also, it seems like this graph is kind of like more stretching vertically. This one over here, it's kind of a little bit wider and also have different vertex. And then 37, describe the transformations. So the transformation here is just showing that the graph would be vertically shrink by the factor of 3 or 1/3. And then it's being shifted 1 unit to the right because h is 1. And then k is 2 units down. Or we can say that the center is 1 unit down, 2 units to the 1 unit to the right, 2 units down. So h is 1, k is 2. And then it shrinks the graph vertically by the factor of 1/3. Okay, so now going back to the page, is that what we got for this whole unit here? Yes, that's it pretty much. So once again, if you guys do like the video, so please subscribe to the channel, click the like button, and then click the bell, and I'll see you next time. Thank you for watching it. Once again, take care.